Now, moving further with the question again, now they're asking us to consider another function, w of x, which is simply the exponential function e to the power of x. Again, x takes in real values. And now for e of x, they also give us the expression on how to find the curvature and the change of curvature. So k derivative. Now in part D1, they're asking us to show that k max is equal to the same, 2 square root of 3 over 9, and it's worth 5 marks. So we just have to figure it out, right? So again, what's the recipe, right? You guys already know this. You first take the derivative of the curvature and you equate it to 0. So in our case, we take our e to the power of x, the numerator, the numerator of the derivative. So e to the power of x minus 2e to x, and we set it equal to 0. Now the funny thing here is that e to the power of x cannot be equal to 0. So that means the only way this is possible is we need 1 over e to x to be equal to 0. And this gives us the fact that e to the power of 2x has to be equal to 1/2. And that means that means e to the power of x has to be equal to 1 over square root of 2. Now, why am I not writing x has to be equal to, I don't know, ln of 1 over square root of 2 or something like that? Because in order to find the k max value, we need to plug in the value of x into k, right? So we need to find k of x. Now, I believe it is much more convenient to directly plug in the value of e to the power of x rather than the value of x, which is not a super nice number. So here is just a simple suggestion, right? You could have expressed this as x equals to, I don't know, ln of 1 over square root of 2 or something like that, which could have simplified to 1/2 ln of 1/2 and then plugged in the value of x into k of x, which isn't super nice, right? I think you agree that isn't super nice, but I'm just going to leave it here so that you guys, right, if you follow this, you can do this. However, I, on the other hand, prefer simplicity in life, so I'm going to do k of e to the power of x, which is 1 over square root of 2. Now, the good thing here is that it's basically the same as k of x. We already showed this before in part C. In part C2, actually. So k of ex is simply going to give us 1 over square root of 2 divided by 1 plus e to the power of x squared, so 1/2 raised to the power of 3 over 2. And now you already did this calculation. You don't have to show it again. You don't have to write all of this down again, right? Just make a pointer to part C2 or something, and you already have it. It is simply equal to 2 square root of 3 divided by 9. We already showed this. Everything is perfect.